There is a huge black hole in the center of the Milky Way galaxy, multiple thousands and thousands of times bigger than the mass of Sun. So anything which goes from the surface of Earth, there are ellipses. But of course, it may look like just like the surface of Earth itself, it will look like flat for a normal observer. Even the curvature, we don't normally notice the curvature. Similarly, anything which is thrown from the Earth is in an ellipse. But depending upon how much of the segment of the ellipse you are seeing, you feel like it is going straight, etc. 1969, the ISRO established. So the first achievement was in 1975, where you have the Aryabhata. After that, there is no stopping back. The biggest achievement where everybody applauded is the Mangalyaan mission. This is the first time attempt you reached Mars. No other space agency like NASA, ESA, or Chinese, or even Russian, who are the big supporter of ISRO moon mission. No other space agency achieved it. Like first time mission successful.
We are all grieved because of the recent passing of Mr. Ratan Tata sir, and we are going to dedicate this episode to him and to the scientific developments that he has brought to India. So in this episode, we are going to have with us an ISRO scientist, Jijith Nadumuri sir, and we are going to discuss a lot of topics about science, about interspace travel, time travel, about the linkage of mythology and science. And I hope that this will give you a little edge on the scientific understanding that we have. We might have forgotten some things from the school times. A lot of interesting conversation is going to happen. So just tune in and enjoy the podcast. Hello, sir. Welcome to the show. It's really great having you on the show. Somebody from the science fraternity, an organization like ISRO, and we have a lot of questions around science, around ISRO, a bit on the religious aspect of science. First of all, I would like to know a little bit on the solar system. Right, everybody has a basic idea of what solar system is. We have sun in the center, we have planets, but we also don't know that the solar system in its entirety is also moving. We think that the sun is stationary, so we would like to have some more information about the solar system.
Yeah, the general understanding the people have is about the sun as the center, and then you have the 9 planets that in Pluto is now demoted as a minor planet, but of course then 8 planet and Pluto and similar kind of minor planets. So icy planets, we can say it's in the boundary. One important thing is the center of gravity of the different planets and sun. It need not be always the center of the sun, because the center of, for example, if you compare Jupiter and sun, the center of gravity is slightly just outside, slightly to the outside of the sun. So the center of gravity is not always the center, but for a small planet like Earth, their center of gravity becomes like inside the sun. So you say that Earth is revolving around sun, but actually every planet is revolving around the center of gravity. So more or less it is close to sun, so we don't see hardly see any difference. So that is one thing that maybe common people can recognize. Second one is the sun itself is moving around the galaxy. So there is a huge black hole in the center of the Milky Way galaxy, and multiple thousands and thousands of times bigger than the mass of sun. So naturally the same, all the stars in the Milky Way is actually orbiting around that particular center of the galaxy, the huge like a black hole. So then when sun itself is moving, when the planets are moving, it's something like a, if you look at it, a lot of illustrations are nowadays, it's like a kind of a spiral kind of motion, where you have every planet moving around sun, but the sun itself moving, so it causes a kind of a spiral effect. So it's like a spiral coil kind of motion. Same thing, like if you look at the orbit of moon, which was very important during the orbital design of the Chandrayaan spacecrafts. So the moon is also having a kind of same situation, where Earth is moving around sun, but moon is moving around Earth. So then you have another spiral kind of orbit. So that is the kind of orbits kind of you can see the orbit itself have a peculiarity that common people don't notice. The second thing is about solar system means see, now till now we are seeing the planets as light body, like sources of lights. You can see them in the sky, the 5 visible planets. They are for the very ancient period Even the Mahabharata Ramayana period itself, you have see the 5 planets like Mercury, Venus, Mars, this Jupiter and Saturn. And of course, Uranus is slightly visible using the naked eye, but the people have not observed it. Uranus, Neptune, and Pluto through the telescopes. But now our current understanding of the planets is that they are the frontier for the human exploration. They contain a lot of minerals and resources, like whatever the minerals and resources we have on Earth, multiple times of that you have in different this planetary bodies and moons. So you have minerals, like very important minerals like helium 3 etc in moon, which are very useful for future missions. So they can be used for nuclear fuel. You can create nuclear fuel based on that. There is plenty of iron and even gold, diamonds. So some of the planets like Jupiter, Saturn, Uranus, these Neptune, gas giants, they have diamonds, diamonds raining. So that the kind of huge wealth, actually it is like I would say, from an Indian point of view, if you look at Lakshmi is there inside all the planets, a huge amount of wealth. There is a meteor which is completely like made of gold. So if there is a mechanism to bring that meteor or even a part of that meteor on Earth, your gold prices will crash. Of course, it will also make everybody rich, but that much amount of gold is there. So meteors contain precious elements like gold and all the things. So the things are like very exciting. There is a kind of new technology itself just born called space mining. So extraterrestrial mining. Like mining on Earth, you will start mining the nearby planets and asteroids like that.
So, I mean, currently the stage that the science is in, we see that even if we reach moon, it's a great achievement, and many countries are trying to reach Mars now because it's closer to Earth compared to other planets. So, how do you see that we'll be able to reap the benefits that you just mentioned, and go to other planets or let's say meteors and actually be able to get these things there, or is it sustainable, is it possible, right?
Yeah.
How the colonization concept is also there, that okay, we can go on some other planet and human civilization can make a colony there. So how is that
Yeah. Yes.
feasible?
Yeah. So currently, as of today, even though I mentioned that it's a rich and wealth in the these different asteroids and the planets, currently, if you look at the cost benefit analysis, the cost of going there and getting those maybe is equally as costly as getting those minerals and then economically making use of it. So that is the current state, and every technology, every new industry is like that. There will be a stage where the cost of getting those resources is higher than the value the resource itself is generating. But then, just like every other industry in the past, there will be a point of inflection where your space flights become cheap, and then the that happens. That the projection is that that will happen in a few decades. So your cost of the space flight will be reduced, and when you get newer and newer assets, like you have a lunar base on the, I mean, surface of moon, you have a base, and you can create a launch pad on the surface of moon. Then the total cost of launching a vehicle actually reduces. It is counterintuitive, but Earth is a gravity well. So any kind of spacecraft which is launched from Earth, it has to overcome a huge gravity pull of Earth. But once you have a lunar base, itself is a very costly thing. But once you have it, and you have regular flights from moon to other planets, then the cost, see, the gravity itself will reduce by 1 by 6th, but the cost will reduce by 1 by 60th.
Okay,
Huge reduction in the cost.
so the
So,
idea would be that flights or rockets would go from Earth to the moon,
yeah,
and then from moon there will be
yeah,
different mechanisms or
yeah, right.
different
Yeah,
what I
yes.
would say vehicles to launch to another planets.
Yeah. The thing is, you first have focus only on the moon. So with a lot of pain, you establish a lunar base there. So you have a launch pad there. You use moon's own natural resources to create the spacecrafts and launch vehicle, etc. Once you have that, it is a point of acceleration. Yeah, you have a kind of an asset which accelerate or reduce the cost drastically, and then onwards, your launches will take place from moon. with the lesser and lesser dependency on Earth. And then onwards, moon becomes kind of a spaceport for Earth. From there, you can go very quickly. You can go to other planets. The number of frequent shuttles between moon to Mars, for example, will increase. So then the kind of natural resource exploitation or the mining, etc., which can happen in the Mars or the asteroidal belt, that will increase exponentially. And every launch or every space mission will cost lesser and lesser. It will be like as less costly as an air flight. Like now we have flight from New York to Delhi or Delhi to Tokyo. So something like that. It's as like every day there will be some flight going. Some kind of spacecrafts will be traveling from Moon to Mars or to asteroids. Like that. So that is the kind of future. Of course, not it is not like 1 or 2 decades, but by the turn of this century, that will be the reality. And then your cost of each individual flight is reduced, but then the water cost of that value of those minerals that you are extracting will be like multiple times more than the flight cost, and that becomes a very lucrative business
Got it, got it.
like that.
And I think a lot of companies are working on interplanetary travel, going from Earth to Mars or to different planets like SpaceX.
Yes,
And
yes,
India is also exploring the possibility of going to Mars now.
yes, yes.
So before Mars, I mean, as we know that India landed on Moon. Can you tell us about some important achievements in this mission? How is it valuable, and how was that achieved?
Yeah, the Chandrayaan mission that you are talking about. So there were three missions: Chandrayaan one, Chandrayaan two, and Chandrayaan three. So Chandrayaan one basically is the biggest discovery of about water. So that's again very important for India because in Indian literature, Earth, the moon is called moist or the producer of moisture, and moon is sometimes called Ardra, which is like it is a moist kind of source of moisture, etc. So, but it is only in the literature. But then the Indian Space Research Organization found out water H2O molecules on the soil, inside the soil, especially wherever the craters are there. There will be shadow region in any crater where the sunlight will be very less. Mostly, sometimes some of them are be permanent darkness, or maybe a few hours of light and most of the time darkness. So there is water there. And not only that, if you dig deeper into the lunar surface, you have water ice, especially in the polar region, North Polar region, there is water ice. That is just like rocks on the surface of Earth. There are water ice on the surface of the moon in the polar regions. So this discovery of water is the most important in the Chandrayaan one. And of course, it also discovered a lot of minerals like potassium, sodium, and other thing. And Chandrayaan 2, of course, the lander failed, but the orbiter is still active. So the orbiter is giving you a lot of information about the mineral composition. And Chandrayaan 3 again a success. So we have launched there this Vikram lander and this Pragyan rover, and it discovered a lot of things. Of course, it reinforced the water discovery again. It reinforced that, and it also discovered this sodium and magnesium and so many other minerals, helium 3 and oxygen, all these things in the soil. Like soil means surface, as well as a very small atmosphere is there. Even though we say moon doesn't have an atmosphere, it has got a micro atmosphere just on the surface. So in that atmosphere there is oxygen and other kind of very important for the human beings to settle there.
I mean, one question on that.
Yeah.
So, why is it that important, or I mean, something to be really alarmed of in a happy way? Is it because it indicates the possibility of life on Moon, some kind of organisms?
Yeah, I mean that will be a little bit far fetched to say, because when I say atmosphere, it is like a kind of extremely thin micro atmosphere. I mean, theoretically it's an atmosphere, but actually it is not. But of course, when you say life on a planet, we will best better talk about Europa. That the Jovian and the Saturn moons, they have more high probability. When people are speculating about a bacterial or a viral life, but what is understanding is, in case of moon, the presence of water means there is a. We don't say that life on moon, but life can sustain on moon in future. Like for example, ISRO or any other organization, NASA, and they can establish a lunar base there. And one more thing they have discovered is there are lava. No, there was a volcanic activity in moon, and volcanoes create cavities. So of course, if you look at on Earth, now the volcanoes come from deep into the mantle and pass through the crust of the planet or the moon. So same kind of volcanic activity happened on moon. So it created cavities like caves. So what is the significance of it? You can actually create natural habitats inside the moon, because these cavities are like radiation resistant. So the surface of moon is completely bombarded with the radiation, solar radiation, and it contains harmful X-rays, etc. So definitely we have to dig deeper into the moon to create a lunar base where there are no radiation and people can live there permanently. Just like in space station, people are living. People can live inside moon permanently, like many years you can live. But then you have a natural. So if you are digging, that itself is a $1 billion activity.
Yeah.
But you already have these caves, cavities, few kilometer deep into the moon because of the volcanic activity. So these are dead volcanoes. So now there is no activity inside that volcanoes, but they have natural cavities going deep 1 or 2 kilometer or 2 3 kilometer deeper into the moon, which can be converted into lunar base, and you can live happily there, and there is water there. So then you have a sustainable life possible there.
And the radiation is more because of the absence of atmosphere.
Atmosphere. So
Okay.
I say atmosphere when I say it is a very, in terms of pressure, it is millions of times lesser, 1/millionth of the time lesser. So it's not a breathable atmosphere, but it doesn't stop any radiation or anything. So it's keep on this solar radiation will keep on bombarding. That's why our satellites get defunct after few days. The this Chandrayaan 3 it stopped working because of this kind of harsh climate there.
Okay.
Yeah.
Okay.
Yeah.
And the next thing I would like the viewers to know is how the mechanism of these rockets going from Earth to escaping the atmosphere actually goes, and what is the path. I mean, we don't, not everybody knows that it's an elliptical path that we have to take,
Yeah. Yes.
and what is the escape velocity. Can you put some light on that?
Yeah. So the launch from surface of Earth. So that's what we call as a gravity well. It means there is a gravity of Earth we need to overcome. So there is a kind of acceleration, the speed of acceleration that is itself is the signature mark of the Earth's gravity well. That is 9.8 meter per second. So any kind of rocket or anything, even if you throw a stone, if it have that kind of escape velocity, then it will escape from the gravity of Earth and it becomes free of the Earth's gravity. Actually, what it means that it will become theoretically it become something that orbit the sun. So if you escape Earth's gravity, then you orbit the sun. So that's the kind of scenario. So for that, what we do is the rocket is the primary mechanism by which a satellite is taken out of the Earth's gravity well. So rocket or launch vehicle we call it. So it has got various stages. Like there is, for example, GSLV where I have worked extensively. There is a cryo stage, which is the main stage, which is the biggest puller of the satellite. But the first stages is like a solid booster stage and a liquid propulsion, four strap-on rockets which are made of liquid fuel. So there is solid propulsion, liquid propulsion, and then there are such two stages. In the third stage, you have a GSLV. Sorry, the cryo stage of the GSLV, where you have the cryogenic gases, liquid oxygen, liquid nitrogen, and liquid hydrogen. So nitrogen is kind of a neutral gas, and oxygen is the oxidizer, and hydrogen is the fuel. So these are combined inside the cryogenic engine and creates a maximum thrust, because of which it goes to very far away distance. So the first two stages, the solid rockets, solid booster rockets, etc., that will initial thrust it will give, like just starting lifting off from the ground, and after it goes to the upper atmosphere, the further distance is covered by the cryogenic stage. So it can go to 36,000 kilometer away from the surface of Earth. So it become a geosynchronous orbit. So once you are in a geosynchronous orbit, you can use it. Geosynchronous means anything that is orbiting in that orbit will be appear stationary to the surface of Earth, because it is equal to the speed of rotation of Earth. So such orbits are used for communication satellites. So they, for anybody who are observing from Earth, they appear as if it is stationary, like similar to how when you have a car, another car is also moving the same speed, then you feel like the other car is stationary.
In the orbit, if we are in a particular orbit, there's a speed associated with that orbit.
Yes. So
Okay.
every distance there is a speed associated with it. So that's again the equation of the gravity. So where the no, the gravitational pull is inversely proportional to the radius. So that equation is what giving you the speed. So when you are in a certain orbit, your speed of the satellite as well as the rotation speed of Earth match. So they look up like stationary.
Got it. The gravitational pull, I remember G into M1 M2 by R
Yeah,
square,
right.
so proportional to R square,
Yeah,
inversely proportional to R
yeah,
square.
right.
How do we see actually rockets going from Earth to another planet, or let's say moon, right? We normally visualize it like it's going in a straight manner, right? But what actually happens is it goes straight, then it goes to an orbit, and then it starts elliptical manner.
Yeah,
Revolving.
Anything which goes from the surface of Earth, they are all ellipses. But of course, it may look like just like the surface of Earth itself will look like flat for a normal observer. Even the curvature, we don't normally notice the curvature. Similarly, anything which is thrown from the Earth is in an ellipse. But depending upon how much of the segment of the ellipse you are seeing, you feel like it is going straight, etc. So of course, the stages, for example, if I can explain the stages to go to moon. So the whatever is you launched, it will goes in an elliptical orbit, but it may look like a straight line, but it is an ellipse, and it reaches the geosynchronous orbit of around Earth. So it is rotating around Earth in an orbit of 36,000 kilometer. From there, then of course, what is orbiting is a satellite, which is supposed to go to moon. Rockets are already expired, like different stages. It's like Diwali rocket, right? It destroys. So the remaining satellite is the top part of the satellite is encapsulated in the top part of the rocket above the cryo stage. That opens up and satellite release. So that satellite is in the geosynchronous orbit. From there, the satellite have its own motor, liquid apogee motor. So whenever the time comes, it is initiated. Then the satellites move towards an orbit around moon. So the moon is also moving. So you basically do a tensor calculus, solve the multi-body problem of a tensor calculus, and you get the correct orbit. And then this geos from the geosynchronous orbit, you kind of an egg-shaped kind of an orbit, and the other end of that egg-shaped orbit is the lunar orbit. So then once you reach that, this particular orbit is called the GTO to lunar orbit transit orbit. So lunar transit orbit, that's an egg-shaped ellipsoid orbit. Egg-shaped, no, it becomes an ellipse, but egg-shaped orbit. End of it, you have the lunar orbit. Again, an ellipse around moon. So of course, when you look at it, look like a circular orbit, but it is light elliptical in nature. So after that, that is called the spacecraft is now rotating around moon. From there, you will have a lunar landing module, which is again separate from the orbiter. The landing module will separate, and it will lands on this surface of the moon. That is a Vikram lander. And inside the Vikram lander, you have the last one, that is a rover, which comes out of the lander and then start the mission of moving around moon. So it's a multi-stage kind of.
So, I mean, if we try to understand it simply, it appears more that the rocket goes always only to a geosynchronous orbit. Then after
Not
that,
yeah. Sometimes it is a polar orbit also, like 100-kilometer orbit also. Some of the spacecraft go to the 100-kilometer orbit. So they are not, the purpose is not to be geosynchronous. They can be like rotating in faster than the speed rotation of Earth. So of course, depending upon the mission requirement, the satellite goes to a 100-kilometer LEO orbit, low Earth orbit. LEO, it is called LEO orbit. So low Earth orbit, geosynchronous orbit, or some other orbit also. But different stages. First is a orbit around Earth. Then you have a transit orbit. Then you have that target target object orbit around target object. This time it is moon, so it's a lunar orbit. It could be Mars, then it is a orbit around Mars, like that.
then the calculations would be to
Yeah.
put it in that particular gravitational
Yeah. Yes.
orbit
Yes.
around that particular body.
Right.
Okay, okay.
Yeah.
And talking about all this, what are the key projects and achievements of ISRO? We know Mars mission and the lunar project that we talked about. What are the key things that ISRO is working on currently?
1969, the Israel is established. So the first achievement was in 1975, where you have the this Aribata. Now after that, there is no stopping back. We have the INSAT series, where I have also worked in the GSLV INSAT. That is a sat communication satellites in the geosynchronous orbit. And then the biggest achievement, where everybody uploaded, is the Mangalyaan mission. This is the first time attempt you reached Mars. No other space agency like NASA, ESA, or Chinese, or even Russian, who are the big supporter of ISRO moon mission. No other space agency achieved it. Like first time mission successful, Mangalyaan mission, the Mangalyaan 1. So we straight away went to Mars and started orbiting it, generated the parameters, study parameters. So Mangalyaan was a great success. Chandrayaan is another one, Chandrayaan 1, where I have contributed. Though that is also kind of a successful mission, because there was an only plan of orbiting around the moon. We did that, and we have an additional thing that is done, which is not really part of the mission. That is a extra bonus. Some like you have a impact mission, like a part of the Chandrayaan orbiter separated, and it crash landed on the surface of moon intentionally, so that you can study the crash and then understand how to land on the moon. So that was the big success, Chandrayaan 1. Chandrayaan 2, little failure, but the orbiter is still functional. And then Chandrayaan 3 is a super success, because while Chandrayaan 3, we had a competition from Russian spacecraft, but Russians, who more or less supported and taught us to launch spacecraft, their mission failed, and we succeeded in landing the on the surface. Of course, it's a kind of healthy competition. Nobody is against anybody. So that has happened. So that's again a great success. So these are the past, I would say. And of course, there are so many other missions which is not creating much sensation, like Aditya L1, which is the study of the sun. So again, it's located in Lagrange point, where there is a very high stable orbit. We don't have to spend much fuel to stay there. Again, a success. And we have XPOSAT, which is kind of X-ray study of the X-ray universe, X-ray radiation from the universe. And then the AstroSat, which is like a telescope. So like a kind of it's ISRO's own space telescope kind of thing. And we have multispectrometer kind of. So because multispectral maps are very high costly, I mean very high in demand, like to study the surface of Earth, like agricultural lands, etc., which are less known, but again a successful kind of ISRO missions.
So I have two questions on that. One is ISRO also working on some secret projects which are not there in the public domain? Second would be, you mentioned great achievements of ISRO and scientists. So even after being less funded compared to organizations like NASA or Russian space exploration, why do you think that Indian scientists are able to achieve so much greatness even if we have less resources?
The one is the thing is that this all I see in this works with passion. They are like, for example, if you are in a love affair, you don't really care about how much effort you're spending or anything. So it's like more or less everybody, like the chairman and all the team members, they are in love with that job. So they don't care. I mean, they work maybe instead of 9 hours, they work. So people say that IT industry works a lot more than 9 hours, 16 hours, etc. But so I have seen, even including I have worked with more than 9 hours to 16 hours, or sometimes the launch happens. It is 48-hour countdown. 48 hours means more than double that one, like so 2 days continuous. So there are people who will be continuously working for 16 or 20 hours and reluctant to go to sleep. Then somebody has to tell, like, you go sleep and come back. Of course, there will be backups, etc. But that is the kind of that could be one of the reason why the things are very successful and moving.
And how do things actually move from ideation to actual implementation, right? You have an idea that okay, we have to go to Mars, we have to go to moon, we have to go to sun, right? In terms of development of technology, because everything is getting created new, right? So how does that process work?
Yeah. So again, the like the previous question, the passion drives it. But of course, we have a kind of divisions. ISRO have a divisions like program planning, etc., wherein the whatever your dream. So the Dr. APJ Abdul Kalam mentioned dream. So like that. So first you have the dream, and then you put it into a kind of a chart, kind of a flow chart, etc. And different component like technology is like lacking. So that some team will be start working on that, getting that technology. There are multiple options of developing it in house or acquiring it from other space agencies. So any of this path they will take, and then there will be other things like budget resources. So there will be some team working on it, working with the government to get the enough budget, etc. And there are other people who do the domestic, like there will be like every mission have maybe some 15, 20 to 25 different departments, etc. Will be different programs will be there. So there is a program planning, program management, etc. And there will be mission is the highest level. For example, Chandrayaan mission means that is the highest level of the organization. I mean, the hierarchy. In that Chandrayaan mission, which will be running for 2-3 years, you have programs which are lasting for 6 months or one year, etc. Within the inside the program, there will be program managers in that. There will be the projects, different projects, etc. So project will have a team. So it's a hierarchy, which will be the higher level. There is a mission. So there is a mission director who is handling the entire mission. Under them there are programs, and under that programs projects, and projects of different nature, like some of them are discoveries, some of them are technology enhancements, in-house technology, acquiring technology, training. So it's like so many other things combined together. It's like an orchestra, and then 2-3 years, then the mission
Okay.
successful.
And coming to the question that we missed, are there any secret projects also?
Yeah. So something I don't want to talk about, but of course, there are like some of the thing don't I can tell. See, there is ISRO, and then you have, the kind of the missile technology, etc. is related to the launch vehicle technology. So there are technological back and forth. So there will be technology advice to the DRDO or vice versa. So those things, these are open secrets, so I can talk about. So they are there. So there will be, like, for example, if there is a missile, Agni missile, actually. So in that there is solid propellants. They are using solid propellants. So sometimes liquid propellants are using. So ISRO being a launch expert, where these launch vehicles are like more or less a kind of missile, but of course not for defense purpose. It is for the space purpose, but this is repurposing for the defense purposes. So there will be some kind of advices or technology exchanges between the organizations. So
Okay.
like that.
So, I mean, now I want to move a little bit onto larger than life concepts, but from a scientific viewpoint, right? So, I'm going to ask you some of your thoughts on these questions that I have. First is from uh, theory of relativity perspective. Is time travel possible? Right. So we know that in Einstein said that it's not possible to move beyond the speed of light, right, which is 3.8 meter per second square, right? And but what I understand is also that for time travel you have to travel faster than light. So from that perspective, is it possible to travel?
Currently, like most of the scientists, they are of the opinion that time travel is only an engineering problem now, because theoretically it is possible. So theoretically possible means like Einstein's theory of relativity mentions that the time is a direction. So when I say time is a direction, means like if you can go to east and west, north and south, or upward or downward. So these are the three-dimensional directions. So as per the Einstein's theory of relativity, you can also go to future and past. These are the two time directions. So just like east and west, north and south, up and down, you can go future and past. Those are theoretically there is no prohibition in going into future or past. So that is what Einstein's theory of relativity mentions. So theoretically there are no prohibitions. But then, of course, even though when I say theoretically no prohibition, there are certain laws of thermodynamics, etc., which create certain difficulty in like moving. Like it's if when I say there is a theoretical possibility, but there are checks and balances in theory itself, that you should not break the law of thermodynamics, etc. Then there is a law of infodynamics, and there is a, like, for example, if information is going from future to past, then like it can violate causality, like for example the grandfather paradox, etc. You might have heard, like a grandson goes to the past and kills his grandfather. So that means once the grandfather is not there, his father is not, he himself is not there. So there is a grandfather paradox. So these are certain, even the within the theory itself, there are that certain checks and balances. But now there are solutions for all these things. Like grandfather paradox is solved by the multiverse theory. So that means instead of one universe, you have multiple universes. So when a grandson is going to back and goes to his past and kills his grandfather, that happens only in one of the universes. But in the other universe, the grandson still exists. So grandfather paradox doesn't work. And then the this theory of entropy and other theories which can interfere with time travel, there are explanations already has come. There are possibilities like overcoming the speed of light. So speed of light, because you don't have to actually travel in the speed of light. That is the current understanding, because the black holes. So black holes create bend the space and time. So when you are actually going through a black hole means it will create a wormhole also, like something like I mentioned, the lunar volcanic cavity, something like that. But it is a four-dimensional thing happen in the space time.
Can you explain a bit on the black hole also? What is the black hole concept?
Yeah. So the black hole is kind of very highly concentrated mass. So, for example, when a star is in a prime age, after overcome its prime age, it becomes a red giant. Red giant means it's an expansion situation, where the gravity is what do you call, gravity is exceeding the or the gravitational force is unable to control the expansion forces. Expansion is happening because of the burning of helium, etc. So then the star will expand. After that, it shall get destroyed. Like the stars, the corona, that is the outer surface, got expand. It's used, so just like a balloon, it bursts, like it goes off. So that's a red giant stage. After that, the core part of the star, it will contract, so that it become a white dwarf, for example. The which is like entire mass of the sun compressed into the size of Earth. That is kind of a white dwarf. After the some of the stars which have more mass than sun, they will compress even further. After white dwarf, it become a neutron star, which means the atoms are also collapsed. So only you have neutrons. So because electrons and protons combine and it become neutralized. So only neutrons are there. So that is a neutron star. And even further, if there is a star have a more mass, it will not stop at being a neutron star. It will even compress. So that is like the size, the mass of hundreds of suns compressed into the size of a football, for example. That much small size, huge mass compressed into a very small size, that become a black hole. So when it is become a black hole, even its gravity is so heavy, so powerful that sunlight, that is photons, hitting on it will not come out of it. So that means the surface, it will look like a black, if the light is not emitted, it looks black. So that becomes a black hole. So that is a black hole. And of course, because of the gravity, the entire surrounding of the black hole, the so strong gravity, the space and time get bent. And so we have to see, when you in the space, when you imagine black hole, it's like a kind of a dark spot or something, because in the backdrop of a star, it looks like a black spot, or a whirlpool. But if you,
But things are rotating around that.
yeah,
That's how
yeah,
we see the black hole is there.
yeah,
Because black hole in itself we cannot
we
see.
cannot see, but in the boundary, then some light can escape. So that way you can detect a black hole. It looks like a kind of a aberration in the background of the stars. If a black hole move around the background of a star, you feel like something, some invisible thing is moving around, creating some distortions. But if you have a representation of the black hole with the fourth dimension, it look like a funnel, like the funnel, like where you pour oil, then so it looks like a funnel, because the center part of the black hole is extended like a pipe in the fourth dimension. That is the hole we are talking about. So if there is two such black holes on the two end of the space time, one act like an entry point, another act like an exit point, that is a wormhole. So
Okay.
black hole and white hole. The other hole is called white hole. So they can combinedly form wormholes, and these wormholes are actually pathways into past. You can go into the past, or you can go into the future. All these things possible.
How to actually understand it? I mean, bending of space and time, when we
Ah,
see that time is just a linear way of how we progress in life, right? Somebody
mm,
was a youngster, then he graduated to being an older guy,
mm,
and once he was a baby. So that's a timeline that
mm,
maybe biologically,
mm.
if an entity is moving like a human being, right? So if we are talking about going back into time or bending of space and time, how do we actually
Yeah, yes.
understand it?
Correct, correct. So this is also kind of an illusion. Like the way we perceive time is more or less how we feel the surface of Earth is flat. In reality, it is a sphere, but you feel like it is flat. So something similar is about time. In our normal environment, time is a linear. It's moving very linearly. Like you don't even see any distortion. Like exactly 24 hours, another day comes, or your birth to death, everything is in a sequence. Not a problem. But when you are in a larger scale, when you are in a cosmic scale, the Einstein theory of relativity is what derives time. So in that, time is a direction. So that is our first step to understand what is time. It's a direction like past, future, and I mean, sorry, a direction like a north, west, north, south, east, west, up, down. So it's a direction. So that is our first shift in the understanding of what is time. Second is like now heavy gravity can bend time. So no two people in the universe. Of course, when I'm not talking about two people on Earth, but different stars, etc., they perceive time as same. So whatever is past for you may not be the past for another person, because it's all dependent upon the velocity of the person, etc. So the normal understanding of a time breakdown, and of course, in a kind of very high gravity environment like a black hole, things are completely breaks down to for a toss. So wherein you whatever time you spend near a black hole for 1 second, it becomes maybe a year or 100 years for anybody on Earth. So the flow of time itself is different in different contexts or environments in our universe.
So if somebody, like it's shown in the famous movies like
Mm.
Interstellar and Gravity also.
Yeah.
So if somebody is, let's say, going near a black hole, you are saying that he will age comparatively less
Yes.
compared to people on Earth,
Yeah.
and their biology also follows that time
Yeah.
of
Everything. It's a yes.
relativity.
Yes. Yes. It's like a real. It's not like a faked one. It is a really the time goes slower there, even including the biological clock. Everything slows down,
So
and it's
then it seems that time is actually a
yeah.
dimension,
Yes.
right? And if we change that dimension, and if we go interplanetary or outside space,
Mm.
then the body also starts behaving according to that
Yeah.
timeline.
Yes. Yes.
Okay.
Like the time is a dimension. It is a direction, and it can also bend and distort like your space. It can bend and distort. So these are a lot of properties of
You also talked about multiverse. What
yeah.
exactly is multiverse concept for the audience?
The multiverse concept is actually started appearing in our theory because it can explain the grandfather paradox, for example, time travel. So some causality problem like when you go from future to past, your cause effect relationship will get affected. So multiverse solves that problem. And even in quantum physics, certain theory, some phenomena, if you want to explain, you cannot explain it with a single universe. So there also the multiverse is a necessity. So it's a mathematical necessity which is derived out of theories like theory of relativity and quantum theory. Both of the theories require that universe is not single. It requires multiple copies of the universe. So in quantum theory, how it comes is like for example, what it says that in every instant, whenever a decision is made, that decision will cause to split the universe into two parts. One is if it is a yes or no decision. Wherever you took yes, that become another universe. Wherever you took no, another it become another universe. Like that. So any decisions you make that result into a branching of the universe, and it is keep on creating every decision, keep on creating infinite number of universes.
Is it in the same physical space or somewhere outside in the space that these universes are getting created, or just meant? I mean, we know from this concept of duality that everything is in a wave form and a particle form. So when we are talking about multiverse, does it touch upon that concept that everything is in a wave form, that different types of multiverses are there?
The multiverse concept is not related to the dual nature, but it is related to the probability. There is a certain probability, right? For example, if it is a electron, so the electron is a kind of a particle, and it's also having a wave nature. So because of that, we cannot pinpoint the electron in a particular spot around the nucleus. Instead of
Yeah.
that, you want to see is that it's a kind of a cloud, a probability cloud. So the probability is what cause. Like probability means there are different possibilities of finding an electron. So your observation, like if you make an observation, then your electron can be in this space or that space, etc. So these different choices, different choices of where the electron is, that can be conceived as a multiverse also.
This is getting really interesting.
Yeah.
And I mean, I've also heard about the concept being explained a bit in our religious texts. Like in the
Yeah.
life of Krishna, there was an instant when Brahmaji is depicted to have come to earth, and by the time he did some of his leela, Krishna could recreate his friend, right, playing, and there was a dimension of this space travel time concept there. Can
Yeah.
you
Yeah.
explain a bit on that?
Yeah. So what is interesting is that our literature, ancient literature, they have so it's not straightforward science, but many phenomena related to this science is somehow in bits and pieces encoded into the literature. So a multiverse theory, for example, it has come in the normal, I mean, our modern science in 21st century. See, maybe after it is, even after 1900 it has come. But one of the important principle of multiverse is that multiple copies of a same person. So in that Krishna-Brahma story, you have that same, even though they doesn't explain multiverse or anything, you can have that get concept that there are multiple Brahmas. So yeah, this is a very kind of you can say it will actually leads to a lot of inquiry. Now, how even though it's in the whatever in Krishna Brahma story, it's not related to quantum physics, but still that concept is there, like a same person, multiple copies, infinite copies of that. And similarly, time travel. There is a concept of Balrama marrying Revati. So one of them is that this Revati and her father goes to the like vicinity of Brahma in Brahma Loga. They said that my daughter. So Revati's father says my daughter need a good husband, so that is why we came here. Then Brahma says like the few moments you spend here, that time thousands of years have elapsed on the earth. So once you return back, you don't see anybody you know, and you don't see anybody you're familiar with in your life once you return back. What are you saying? Don't worry, because now the Dwapara Yuga, the Krishna is born and his elder brother Balrama is a bachelor looking for a wife, so you can become his wife. So here also theory of relativity is not there, but you can see that time dilation. That is, at in certain places in the universe, the time is moving slower, and once you return back to Earth, you can really feel that time has elapsed in a different speed. That you can see in this particular
So the
narrative.
least that we can say is, even if technology was not there,
Hmm.
right? But people at that time had a
Yeah.
good understanding of all these concepts of time dilation, how time
Yes.
differentiates in different locations,
Yeah.
right?
Yes.
And
Yes.
maybe what we see as different stories,
Yeah.
they have tried to capture the essence of science there.
Yeah. Yeah. I have a kind of interesting postulation there, which especially because most of the theories come in the, even though you see it in the Puranas as very ancient literature, These stories are added somewhere between the Sunga and Gupta period. So they have a very advanced science. So the Gupta era science is thousand years more advanced than the 14th century science in Europe, because you know a lot of literature related to science and mathematics they copied in the Europe. So Gupta era ended around fourth to sixth century CE, and European Renaissance from 14 to 16th century. So 10 years gap. So how they achieved the advancement? European world is now leading in science because they have taken the Gupta era literature, the Gupta era scientific literature, mathematical literature from the 4th to 6th century is completely transposed to the 14th to 16th century of Europe. So, of course, in the Puranas, what we see is a literature version of the science. Actual science, we don't know. So, in the actual science, whether the Guptas they have, because they are very advanced, they are very close to the discovery of calculus, etc. So, most of the gravitational related knowledge they had, mathematics, integration, differentiation level, that kind of their science mathematics progressing to that level. So it is possible that there are certain science and technology and mathematics in the Gupta era period, which actual text we don't know, but poets started getting the essence of it and getting captured into the stories in the Puranas. That is a real possibility.
In whole of this concept, I mean, if we are talking about all these different concepts of, let's say, time dilation and travel and time travel, so it is also possible that if technologically we are progressing to go there, then in the near future or distant future we'll get there,
Yeah,
right? It means that people from future might already be there on, right?
yeah,
Because in future the technology will be there to go back in time,
yeah.
right? So people would be there from future in present times and also in the past that we have there, that we have lived. So maybe the technology that Mahabharata and all is talking about, even though it was not possible at that time, but people from future have come and implemented some of the things there, or from some of the different planets.
There is a kind of a possibility, but I have also explored no, the information sequence in the ancient period from Rig Veda to Ramayana to Mahabharata. So what I have seen is that in the very ancient period, for example, in the Rig Veda, there is no such magical information about people coming or going, but the Vimana concept, that is we can see from Ramayana onwards, and the Mahabharata it is little more enriched with a lot of realistic depictions of the Vimana, like engines, etc. is mentioned. So yeah, there is a theoretical possibility of people moving in different time, but my understanding when I looked at the literature, the information which is talking about this or information which is very close to time travel or paranormal activity, those are kind of towards a later period. So somewhere in the Sunga Gupta period, etc. So it's a possible that because the Mahabharata and Ramayana have evolved from the period of their lifetime, like Pandava lifetime or Rama's lifetime, to very late period like Gupta or Sunga period. So in this long period of time, there could be some kind of exchanges from future to past, or it could be a kind of a natural growth of the information because Gupta, as I said, very advanced in mathematics and physics or science. So what I'm saying is this information, the information of what future to past, the high probability of it occur is in this period, like in a later period, because that is what the information sequence tells us. But there is always a possibility that this kind of things are theoretically possible like that.
And from science perspective, uh, a lot of people spend time, their minds, whether there is a presence of soul in the body,
Mm.
right? And what does that mean? So from science perspective, do you think that people should actually devote some time in doing all these soul searching, self realization, and all these things.
Yeah, yeah. So this is one area where, like for example, the whatever the outer phenomena that is completely in the subject of physics and mathematics, what happens inside the human mind. That's the in still like there is that is the area where science have not made much progress. But Indian concepts, Indian philosophy, our Bharatiya tradition, it has a lot of insights. So, for example, the theory of karma that can be considered as kind of a theory which is where the science have not entered, but there is an explanation provided from the tradition. So, as part of that, there is an Atman, so which takes up the kind of memory imprints, and to that extent, even science also agree that is the brain records memories. So, but of course, the science doesn't tell about what happens after death. But our traditionally that what we consider is that there is a kosha, there is a kind of part of our body which is surviving the death. The death happens to our body, but our a part of us which is not part of our body, which we call, of course, we call soul or atman, which has got a memory imprint of whatever happened on the earth. So our memories are, as per our traditional, it's not science, but our traditional understanding, our memories and our imprints about life, current life is not ending, but it is carrying forward. We don't take, like people say, now we don't take the wealth we generated. We don't take our dress or any kind of possessions, but we may take our memories. And with these memories, we go into a kind of journey. And with these memories, or because of the memories, we have got a direction in the afterlife. As a result of direction, we may be born again. No? That is the rebirth concept with those memories. So that is the concept of karma theory. And of course, it also means that if you are performing certain actions which are not desirable, then as a consequence of that, you get a different life where because of that undesirable actions you perform, you may get difficulties. So some people are born blind. Some people are born with diseases, etc.
Is there any exploration from science perspective also on this? Any
Yeah,
iota of
yeah.
validation that science can provide on this
So
concept?
only at the edge, I would say. For example, the last stages of the death of a person, then there are certain scientific studies which says that a lot of neural activity happen on the brain, which is unless because there is an explanation for it. But one person is dying, what is the neural activity going on? So people have tried to understand it's not about this neural activity is not related to pain or anything, because of course a lot of pain happens, then people some neurons will fire, but not that. They have discovered that this neural activity is somewhat like recollecting, like something remembering. When the brain tries to remember, that is the kind of signature you get in the neural activity. So what is that? So there is so science have only up to the last moment of death. That is only the science knows. But our literature says that when you have a near death experience, you will remember. I mean, you will pass through all your events happening in your life.
And that is kind of in sync
Yeah,
with what
yeah.
scientists have
So there is a
discovered.
correlation.
Correlation, yeah.
So science says that brain is firing, and our literature says that this
Is a recollection
recollection
of the
happens in the
entire life's memories.
yeah, yes.
Okay.
And then our literature stays further, like it takes away that memory, all the footprints, all the imprints, all your actions that you have performed, and you will self evaluate. Now when you are living, you will be like denying, like I didn't do that, I mean I didn't do that bad, it's my you have justifications. But once you are dead, you will have a first fresh perspective on everything you did, and you can yourself understand, okay, I did wrong or I did right. And based on that, so as per that karma theory, it's not somebody forcing you something. You yourself decide for yourself, okay, I did this, I did that. So I have a new course of action, and that is what rebirth is about.
Okay. And one thing I would really like to know is,
Yeah,
uh, I mean, a lot of information about past
yeah.
would be captured somewhere, right? So when we see about the people who we call gods, let's say Krishna, who recited and told Gita to the world, all these things, and the sound would be there in the universe, right, somewhere. Would it be possible to actually capture these kind of words directly from Krishna, which he said, not just through the books, but somewhere in the future, would we be able to capture his voice?
So a lot of people would like to go to the moment of when Krishna is reciting that Bhagavad Gita, and then if you should be able to record those voices, etc. So those are all very interesting kind of possibilities. But of course, our tradition has done one thing is that we memorize Bhagavad Gita as part of the Mahabharata, and the entire slokas, very close to 100,000 slokas. People were capable of memorizing that. Today, you don't even memorize your own mobile phone number. But imagine the kind of memorization capability. So even though, I mean, the other option is time travel, but something close to time travel, our tradition have achieved by memorizing these slokas for many hundreds of generations. So
Would you
that
be surprised if there are already unknown equipments, right, which were present at that time, which recorded Bhagavad Gita or sayings from people like that, like Jesus?
but currently I don't see anything in literature about recording media. But it will be like very interesting. But I would say that the best recording medium of the ancient period was the human brain, because there is some studies going about Sumerian literature versus Indian literature. So Sumerians were the first, no, or at least most successful in recording information by writing, and our civilization prefer to memorize this in the brain and pass it on to the next generation. Today, when you look at between Sumerian to Indian civilization, both are equally old, uh, thousands of years. In Sumerian written literature, you will only get very few, some epic of Gilgamesh, something like that. In terms of number of slokas or verses, it is very less compared to Rig Veda. So even though we don't have any writing medium, we were successful in recording everything in the human brain and take it into 21st century. Whereas Sumerians, they were very much focused on writing, but they have very less information to the future
Maybe
generation.
we, Indian civilization, also wanted to keep the knowledge only with the right people and not
Yeah,
generalize it to
yeah, yes.
everybody.
Yeah, that's because it's a kind of choice. Because when they looked at the Indian also have the in the script writing, but writing can create errors, because if you use in the script to record the Rigvedic slokas, the suktas, and so the writing is so primitive at that time, how much you will record, and whatever you record, you may not be able to decipher it. Now today you can't decipher the Indus script, and it even if you decipher it, very limited information, 1% of information only you can record it.
And context also may not be
Yeah,
given.
we don't have a context. So now instead of that, you have an entire tradition which records in the brain and then pass on to generation after generation.
Okay. We see a lot of conspiracy theories about aliens, that
Yeah.
NASA has captured some aliens. They have some UFOs also,
Mhm.
right? What are your views on that? And what are ISRO's views on that? Do we work in that direction also to identify some of these things? If we are going out of space, we also have this in mind, that, okay, we might see somebody from the outer planet, be a flying object or something. If the civilizations are there and they are more advanced than us, then they might be present somewhere near us also.
Mhm. Of course, so 80% of the people just are in the just they will deny it. If you ask me, the mainstream narrative is that complete denial actually, right? Nothing happened. Like if you use ChatGPT or if you use anything internet, they will deny it. But now, because even there are space astronauts opened up of their experiences, and I was very much open because when I look at from the theory point of view, there is nothing that prevents in the theory for having the extraterrestrial civilizations, right? Because you have Drake equation and all the thing, which means if there is life on Earth, there are millions of habitable planets possible in the galaxy, based on certain parameters. That is the Drake equation, gives you the exact number of habitable planets in a galaxy. So in that, the habitable planet count comes to around million. whereas the number of stars on in Milky Way is in terms of multiple millions. So, but 1 million habitable planets, around 5%, if I remember correctly, or 2% to 5% habitable planets are there, or stars with habitable planets. So, if your number is that much high, then some of the planets can have, theoretically can have life, and if there is life, some of them can be like started 1,000 years earlier than us, or 10,000 years earlier than this, or a million times earlier than this. There's a possible. So imagine, like, in 21st century we have this much technology. So imagine another civilization starting just like us. What will be their technology if they have little, maybe 1,000 year more advanced? No, their starting point is 1,000 year more earlier than us. How will be their technology? Or if they have 10,000 years earlier, or 1 lakh year earlier, they would have already acquired a capability to come to Earth or other planets. So theoretically, there is nothing preventing, and then the same recognition gives around 36 to around human like, or advanced, more advanced than human kind of civilization also in the galaxy, who can move around anywhere in the galaxy, that kind of capabilities. So when theory is like this, how can we practically deny the presence of extraterrestrials? So that is what I have also my position. And now recently our chairman is ISRO chairman also actually endorsed that point of view. But I would also say what is happening in the ufology currently. Ufology, or the different people claiming to be abducted by the UFOs. So there is a problem, because out of maybe 100 cases, 95 is hoax. That is, people are making it up. That is also true, because a lot of people have gone to claim, then they found it is just a psychological, or somebody want to become famous. They just say I was abducted by the alien. But there are 5% cases which cannot have any explanation, that you can't reduce it to somebody hoaxing you, or somebody having a psychological breakdown. Out of 100 out of 5%, there is a real cases also there.
Okay. Till under the wraps of governments, right?
Yeah, yeah.
They might be working on it.
But officially, like as an official, even US government, where there are a lot of activities, they are officially asked to deny it.
So I think that was really a nice discussion.
Yeah.
We touched upon many points, like very deep science concepts, interplanetary travel, time travel, the possibility of it, and the linking of these concepts with Indian mythology also. I think that was a really great discussion, and I can keep on going and discussing this with you, but given the time constraints, I would like to know some thoughts from you, that now the younger generation is moving away from getting into science domain in depth, and the kind of researches that come out of India are less compared to the Western world. uh, I would like you to basically give a message to the youngsters about the importance of science, what can be achieved, right, and how should they proceed in their lives.
One of the thing is that the 21st century where we are, this is a happening century for, at least for the science and technology and space technology, in a very particular, because now the generative AI, the AI revolution is started. So whatever humans can do and think, much more than that AI will be coming. I mean, even then, even otherwise, even if you forget AI also, the space technology is considered one of the areas where there is a growth. So this is directly beneficial for the future, the current generation, that you can develop some expertise in the space technology, or associate, because in the organization like ISRO has now opened up with a lot of support for private partnership. So you can be an employee of ISRO, or you can be a private employee of a private organization, and then work with ISRO, or you can be a university student, and still there are university student programs with ISRO. So university students are developing satellites which ISRO is launching, and or some space instruments they create, they will go for as a payload for ISRO satellites. So it's like it has opened up. Like, it's not just ISRO. ISRO is just a parent organization, an enabler, where any person, anybody, even a villager born in India, can work on a space project associated with ISRO, either as as part of a university or as a space startup or even private organization. So that's a kind of environment, and you can make innovations like micro satellites or nano satellites, which can at just one launch it can itself start going to Mars or other planets and start exploring. Even that also capabilities are growing. Like, so you can design that satellite, and ISRO will launch it. I mean, the difficult part is taking it from the gravity well of Earth. Once it's out of the gravity of well of Earth, your small satellite, which is as bigger as size of a football, it can go by on its own. It can go to Mars. So you can yourself approach Mars, right, with your small satellite. So that kind of innovations are expected in this current century.
So the possibilities are immense,
Yes.
and people should actually focus and try to get into this field of science. That will be really rewarding also in the future.
Yeah, yeah. And I have also published 3 books, which I would also talk to the audience, which are, of course, it's on the ancient literature, but it has information about some kind of futuristic things or presence of extraterrestrials, which have some interaction with our Aitihasic characters. So anybody interested in looking at that ancient extraterrestrials, etc., they can go and read that. It's published in Amazon. Reverse Shift Rig Veda, Geography of Ramayana and the Geography of Mahabharata.
We'll provide the link in the podcast description
Yeah.
also.
Yeah.
So I would urge the audience to go and read these books. I'm sure
Yeah.
the kind of discussion I had with sir, you'll have similar interesting thoughts in the book, and you can go through that. Thanks a lot, sir, for joining us.
Yeah.
It was great interacting with you, and again, thanks a lot for providing and sharing all your knowledge.